Hello, Wendell. This is Michael West, and for anybody who may have come across this video serendipitously through the web, I'm an instructional technology facilitator, and I want to talk a little bit about a professional development I just came back from, hosted by Dr. Norman Webb of the University of Wisconsin, who is pretty prominent in the education world nowadays due to his depth of knowledge framework he created. So I want to spend some time this afternoon talking a little bit about what that is and how we can apply it to making our lessons in classes more effective. I think a lot of you probably have heard of this depth of knowledge framework, but I'm probably mostly talking to first and second year teachers, in part because this is another framework we can use to, improve our teaching, but it also serves as a guide that helps whether you're a first-year teacher or a fifth-year teacher or a 20-year teacher. It just helps us to better construct questions, to better plan out our lessons. So with that, here we go. Okay, so like I said, I want to discuss today Dr. Norman Webb's Depth of Knowledge Framework, and he is a professor at the University of Wisconsin at Madison. And in particular, his specific field is at the Center for Education Research in Wisconsin. And he developed this framework some years ago, and it's really kind of caught on, particularly with the adoption of Common Core, as it really kind of encourages and pushes students and teachers to begin asking better questions, to begin to get out better assessment data, and to encourage students and teachers alike to incorporate a variety of different texts, prior knowledge, and just various ways of assessing information. So I want to start with this circle illustration, the depth of knowledge wheel, as it were. And I want to point out, actually, this is not actually something created by Dr. Webb himself. He's actually pretty critical of it, and I can obviously see why. According to him, it focuses too much on the verbs, and in his dissertation, what he goes to great lengths to point out is that what's really important is not the verb itself, but what happens after each verb. But I do want to start with this in large part because it is so prevalent out there and has sort of become a part of this this packet. If you usually, like I said, if you do a basic Google search right now and look for depth of knowledge, this is one of the first things that comes up. And it's not a bad starting point as long as we don't see, as long as you don't stay there. In other words, this is something we don't want to get stuck on. We don't want to stop at the verbs and that's the end of this thing. This is just a starting point for us. So with that, I do want to go through each level, and I think these verbs here do provide a pretty easily accessible springboard through which to talk about some of these ideas. So starting with level 1, some of the questions or starting points that this looks like would include the who, what, where, when questions, for example. Asking kids to report, to calculate, to define, to recite, to measure basic information. This is the kind of stuff that in a language arts class, for example, you could ask a student to pull out of a text, like the author's name, the main character, things that students can go back to the text very easily and pull out right out of the black and white text. So there's little of any kind of thinking beyond what's in front of them for this particular level. However, it's important for me to, I think, to point out that this level does not mean it's bad. These levels are not synonymous with, for example, EOG scores, where the 1 is the lowest, 2 is the it's 2, 3, and 4, and then, of course you want to strive for the 4. You don't always need or want to strive for the 4 in this particular case, and I do want to point out that these levels, again, don't represent a continuum of good, better, or best. They are, in math, for example, it's extremely important to memorize, to recall information, to remember formulas, and this is not, again, it's not like a bad measure. It's just we don't want to stay here at level 1. We want to have kids be able to do these things, but don't stay there. So, for example, some of the questions you may ask in depth of knowledge 1 would be, can you recall this formula in math, or in language arts, who was the main character of this particular story? Who was this? When did this happen? Names, dates, facts. Again, things that the kids can pull out from the text just by looking at it, with relatively little effort on their part. And again, it's not a bad thing. It's just it's the most basic level of understanding. So that is the depth of knowledge level 1. Level 2 is more geared towards skills and concepts. And some of the words and phrases associated with this would ask students to separate, to classify, to infer, to determine cause and effect, identify patterns. The first 2 levels here, level 1 and 2, I would say are the largest percentage that make up today's standardized tests. The EOG, even the SATs, many of them don't get much further than the 2 level in their questioning. And that's part of the push for this adoption of this framework is, and again, it's just one more framework we can use, but it's one of those things we want to just, again, we acknowledge that we're there, but we don't want to stay there. In language arts, for example, I would say that level 2 looks like you take a piece of text that you read in class and you ask a kid, for example, to summarize it, looking for evidence in the text that can be pulled but isn't necessarily written there in black and white for them to pull out. They kind of have to do a little bit of thinking on their part. But none of this in level 2 goes beyond the text at hand. It doesn't necessarily ask kids to activate prior knowledge, to make connections across curriculum or subjects. It's limited to the text or the problem, for example, in math, that's directly in front of them. It doesn't require the higher order thinking skills that have kids bring in ideas and content and connections from other subjects. So some of the questions associated with level 2, can you explain how this affected that? How would you apply what you learned here to develop something over here? Compare and contrast, for example, is level 2. How would you classify? What would you say about this, etc. I won't go through every one of these questions, but feel free to sort of pause this video and read them at your leisure. That's level 2. It's using what's in front of them and asking them to think a little bit, basically. Now, level 3 is a more strategic thinking, and I would say that level 3 is about as high as you can expect to get in one single class period of an hour or 90 minutes. There was a story that Dr. Webb shared with us today about how he heard of a principal that sort of forced his staff to always have a level 4 question on the board that would be answered that day. And he's like, well, it's out of the question. It's ridiculous, because the ability to do level 4, it takes not only time but also takes some background and scaffold strategies, and you shouldn't expect to have level 4 every day. And again, that just goes to my point before about how these aren't necessarily good, better, and best in their implementation, but they're just levels of understanding, levels of assessment that we can use to, again, to push kids to give us more, more deep understanding of what they know. So, level 3. The words that this looks like might be, again, assess, construct, appraise, hypothesize, differentiate, cite evidence. And these levels, they do have a tendency to, sort of blur into one another. So there's not always a hard and fast rule that this question's always going to be 3, this question's always going to be 2. You may come across instances where some of them may be 2.5, for example. But, for example, in science class, a level 3 would absolutely be having kids having them do a lab, for example, and then they make a hypothesis, they make a prediction. Because making a hypothesis forces them to take the information in front of them, but also to activate prior knowledge based on what they think will happen. They have to think about what they know about the given situation, and then make connections based on what they think will happen from the past experiences that they may have with that, whatever lab it is. And again, making a logical argument in language arts class, developing a persuasive or argumentative essay would be an example of level 3 here. because we're asking kids to draw connections, to make arguments. And with level 3 and 4, we get into the there's not one good answer for this question. Level 1 and 2, oftentimes there is a, quote, correct answer. Level 3 and 4 ask kids to really get at the heart of what Dr. Ken Robinson calls this abstract thinking. Multiple answers to the same problem, essentially. So critique, collect and display, modify, and sort of defend your thesis. Some questions associated with level 3. How is blank related to this? What conclusions can you draw about blank? How would you adapt this to create a different whatever? Can you predict the outcome if something here was different? And again, to apply this in cross-curricular activities, this is the first level, I would say, that really forces the students to go beyond the text or problem at hand. Level 2, you can read that same article, you can read the Gettysburg Address, for example, and you can talk about just what's there. Whereas level 3 forces kids to do some outside research for, perhaps. Look up what 4 score actually means, go just beyond the text, draw conclusions based on the text, but have to go outside of that text to get the answer, for example. So that's level 3. And finally, level 4 is the last and final here, and this is the kind of thing that you should see on end-of-unit projects, for instance. You're not going to, again, have a level 4 question in every class period, but you should have them several times a year. Some of the things associated with level 4 would be to connect, to design, to synthesize, to prove your answer. Again, level 4 is kind of taking level 3, and it's like kind of level 3 on steroids. It's kind of, over time, develop your argument. So it forces you to go outside of the text. It forces you to bring in multiple media, multiple information sources, and construct a well-thought-out product of some kind. Again, it could be an essay, it might be a presentation, it might be a video or a podcast, whatever that you're trying to have the kids do. It's something that's going to take probably several days or even weeks to complete, which is why it's hard to assess. One of the reasons, again, that our standardized tests limit themselves a lot of times to the 1 and 2 levels is because it's very difficult to assess a level 4 when it's a very complex, very high-order thinking type of problem. Some of the things associated with level 4 would be to write a thesis, draw conclusions from multiple sources, design and conduct an experiment. So in science, for example, it wouldn't just be giving you the experiment or the lab. It would challenge kids to create an experiment based on a question they had, and then gather the information, and then develop alternative explanations for the same results. Again, this abstract thinking idea. Again, write a research paper, apply information from one text to another, and the things in depth of knowledge 4 would most likely be the writing of a research paper or applying information from one text to another. It requires extended time for the thinking to occur. So again, don't necessarily look at this as a good, better, or best continuum, because lots of these things are interrelated, interwoven, and some of them are just downright impossible to do in a single class period. So just keep that in mind. Now this is a matrix here developed by Ms. Karen K. Hess, and she has sort of juxtaposed the revised Bloom's taxonomy with the depth of knowledge framework. So in the left column here you have the revised Bloom's taxonomy, to remember, understand, apply, analyze, evaluate, and create. And she has put this alongside of the depth of knowledge. And a lot of times these things line up nicely. Again, sometimes they don't. But I think it's important to talk about some of these things and what they look like. So again, the depth of knowledge 1 asks kids to recall basic facts. But there's nothing there for level 2, in part because it requires more understanding than just rote memorization. The key I want you to get out of this, and I won't go through each individual box here, but just understand that as they go to the right, the depth of knowledge just gets deeper. And just take note of the fact that there are blank spaces in some of these boxes, again, because the matrix doesn't exactly line up to the depth of knowledge. And I don't want to impress upon you that this is a replacement or a different different format we're all going to go to in a couple years. I think one of the major problems in education today is that the folks at the top always think there's going to be this great, magic bullet that's going to solve all our problems. This is just one more thing that we can look at learning and encourage kids and teachers to create better products for us, to get them to think about things in deeper ways. If you take nothing else from this particular presentation than that's the most important thing I think you should glean from this talk here. So, one of the major things that Dr. Webb has gone to great lengths to describe is what he calls the difference between difficult things and complex things. Just because something is difficult doesn't mean it's complex, and vice versa. The depth of knowledge framework is trying to get at the complex, not the difficult. Okay? So for example, this guy here, his name is Chow Liu. He is the record holder for reciting the most places of pi. Okay? Very difficult thing to do. I mean, it's I don't know how many. I think he somehow got to like 20,000 places. I could be wrong with the number there, but my point is that this feat is extremely difficult. However, it's not very complex. Okay, what's going on here is it's a very level 1 type of rote memorization activity. Nothing is going on here that is complex. It's more than one step. It's asking the person or the student to simply remember and recall the information. Now, complexity looks more like this. In math class, you may have a table, and as you can see, you have apples all along the top. You have 2 apples and 2 bananas along the second row there, and you have a mixture of bananas, cherries, and apples on the the third and fourth row. And the numbers along the right side and the bottom are kind of reminiscent of a Sudoku puzzle. What I want you to glean from this is that this activity requires multiple steps. So to answer this question, we have to figure out, it's very much an algebraic equation. That question mark in the bottom left is very much the x variable here. We've got to figure out. So to do this, a student would have to figure out how much 1 apple is worth. So 28 divided by 4 apples on the top row would obviously equal 7. So that top row would be 4 times 7. And the same could be true as you work your way down through each of these. It would force the student to recognize the relationships, to have multiple steps, and to make a prediction and or conclusion based on the evidence in front of them. So to do the row 2 there, you have the 2 apples and 2 bananas. So if each apple is worth 7, then you could say that the 2 apples on the left side of that row would be 14. And then if the answer at the end is 30, you do 30 minus 14. Of course, that's 16. Each banana is worth 8. And you keep going down the rows as well there. However, there is other ways to solve this problem. There is a rule that states that the sum of the columns equal the sum of the rows. So if you added up all the columns and all the rows, you could arrive at your answer by dividing that way. Again, the important thing to remember here is there's multiple ways to get at the same answer. And this would be, you could go down the rows like this as well. Like I said, you could figure out the answer in multiple paths. And of course the answer here is 25. But this would be very much a level 3 type of problem because it's difficult, but the difficulty isn't our goal here. What our goal here is complexity, to ask kids to understand multiple concepts and then put them all together in a single synthesized format. If that makes sense. So, the key takeaways I want you to have from this presentation. Number 1, the whole purpose of Webb's depth of knowledge is to push students toward more complex tasks. Again, not talking about difficult, we're talking about complex. The second thing, we want to foster learning that seeks to not only draw conclusions in the text at hand, but to activate prior knowledge and make connections to other texts, especially across disciplines. So again, I was talking about how assessments oftentimes only limit themselves to the levels 1 and 2, in part because they're constrained in time and ability to have kids bring in those cross-curricular information they may bring to the table. But I think if tests can't do it, certainly teachers can, and that's the miracle here we're talking about. One of the things that really continues to inspire me is that no matter how good we get with technology, how many assessments we create to better understand how kids learn, the data, the metadata can be aggregated in such a way that we could see a whole lot of different stuff. But at the end of the day, it's still a teacher that has that ultimate power to impact the success and the depth of learning that takes place in the classroom. So the teachers are so, the work that teachers do, the work that we do is so important, but it's also, no one else can do it the way a teacher can. Number 3, this is not a replacement, again, for Bloom's taxonomy or the Common Core standards. I don't want you to think that this is going to be one of those things that just comes down the pike that is going to replace these things. What I want you to take away here is that this is just one more thing that it's a framework that we can use to look at learning. And it is a little bit fluid. In other words, each level can be, there's not just a black and white area between each level. I mean, there's certainly some gray there. So I just want you to just keep that in mind as well. And the last thing, as I mentioned a couple times, is that levels here are not necessarily better or worse. They're just different kinds of learning, and they're all necessary for rigorous classrooms. And that's the key word here, is rigor. The idea and the goal is to create classrooms that get kids to think deeply, to engage in complex tasks, and ultimately provide a rigorous education for them as a whole. So that's pretty much all I wanted to talk to you about today. If you have any questions, please feel free to get in contact with me. I'll leave my information below if you don't know me personally. And if I do know you personally, I'll see you around school. All right? Take care, everyone.